Hello, everybody, and welcome back to another Mr. Farney Earth Science video. In this video, we come to the final little bit of notes in our atmosphere section for meteorology unit titled Clouds and Precipitation. The main focus of this little section is that clouds vary in shape, size, a height of formation, and the type of precipitation that's associated with them. So we're going to talk a little bit about how precipitation happens, types of precipitation, types of clouds, cloud formation, different types of clouds, how we name them, all that fun stuff in this little video. First thing we have to do is we need to look at the difference between stable and unstable air. Can we tell the difference between the two of those and how they kind of play a role in this? Firstly, clouds. What is a cloud? Clouds are billions of tiny water droplets suspended in the air that have condensed because that warm moisture has risen high enough to that LCL mark where we're actually getting cloud formation to happen. What is the big key in making a cloud is we need movement of the atmosphere. We need that convection. We need movement from high to low pressure. We need wind. We need the atmosphere to move in order to make a cloud. If we have a very stable atmosphere, atmospheric stability, it influences whether this movement is going to occur. So if we don't have a lot of wind, if it's a very stable pressure, very stable temperatures, we're not really going to be making a cloud. You need the movement, you need that instability to make clouds actually form. If you watch weather forecasts, meteorologists may say something about, oh, the atmosphere is a little unstable right now, very unstable conditions. That's probably what they're talking about. If there's a lot of movement in the atmosphere, a lot of wind, a lot of temperature differential between, one area and maybe an area right next to it. So first scenario, stable air. The air parcel is the same temperature as the surroundings. We have no vertical movement in our atmosphere, no clouds, very fair weather, very nice days. The air parcel in the second scenario is cooler than the surrounding atmosphere and it sinks. That, it means, again, no clouds, fair weather clouds, very nice days. Sinking air, but that's cold, is not going to give us precipitation or no vertical movement. So if we're talking no movement vertically or sinking air, we get stable, nice weather air. Unstable, the atmosphere is cooler than the temperature of the air kind of parcel or bubble that we're talking about. And because we have that difference in temperature, the clouds are going to rise and begin to gather moisture. And then thunderstorms are generally found within this unstable air because we have a lot of moisture being pushed up very rapidly at specific locations. And we call that atmospheric lifting. There are three ways that we can get air to rise. First of all, convective, sounds kind of like convection, where the air will rise when it's heated and it becomes warmer than the surrounding air. This is the same process that takes place in an unstable atmosphere, and this is a picture. If you have some sort of part of the ground that is radiating energy, warming the air around it, that air is going to rise, and as that warm air rises, it's going to, go up, hit a cooling point, condense into a cloud, and then surrounding it on the outside, we get the development of this convection cell where colder air begins to sink and then filter back in the middle. So we have kind of like these two convection cells on either side of this. Cold air sinking, warm air rising. If we look at this picture here, actually, that cold air sinking we learned on a previous chart is associated with fair weather. So where we have these cold air sinkings on both sides of this chart, you're going to get fair weather. In the middle, in between, where we have that warm air rising cloud formations, this is where we're going to get some storms, some stormy weather here, and probably some precipitation like rain going on here. So where we have that cold sinking air, that's going to be fair. And then in between each of those convection cells, you're going to get some stormy weather because that warm air, it's going to rise, it's going to condense. Those clouds are going to get very heavy and it's going to precipitate there. So that's kind of how convective formations occur. Next one, orographic lifting. This happens when air is forced up and over an elevated land. We'll show a picture of this in a minute. It has to do with mountain ranges. And then convergence, when warm and cold air meet and the warm air is kind of forced upwards. So orographic lifting, you see this a lot out west toward California near the Rockies, where you have some prevailing wind off the ocean that's forcing kind of cloud lines to go toward a mountain range, high elevation mountains. Because it's high elevation, those clouds are going to want to go up over it. So those clouds are going to increase in elevation. And as they increase in elevation, it begins to rain on one side of the mountain. It's going to dump all of its moisture. So then by the time it gets to the other side of the mountain, it creates this rain shadow or an area on the other side of the mountain where it does not rain or precipitate very often. So orographic lifting has to do with some cloud formation being forced up over a mountain range. Convergence lifting, this is when you have winds kind of coming together and then forcing wind upward. So convergence results in the forceful lifting of air. Whenever air converges horizontally, it's got to increase in height to allow for kind of decreased area. So the winds are going to come together like this, they're going to go up, and then they're going to go out. So that's convergence lifting of clouds. Now that we have kind of those basic understandings of kind of how some cloud formations can occur, let's compare, contrast low, middle, high, different types of clouds. So again, clouds form as a rising air mass cools, air pressure decreases. Those water droplets around condensation nuclei form. So you need like a little dust particle or something suspended in the atmosphere for that water vapor to begin condensing on. And then the number of cloud droplets needs to be large enough to make that cloud visible. So we base cloud types based on their altitude and what they look like. And based upon these is how we get all of our cloud names together. So we have strato clouds, alto clouds, cirro clouds, starting with ones low to the ground, kind of middle in the atmosphere, and then ones very high up. And then the appearance type, cumulus are puffy dudes, stratus are smooth gray blanket-like ones, and cirrus are our very light wispy ones. You can combine these together to give all sorts of different types of cloud names. So you can have stratocumulus, you can have altocumulus, you can have altocirrus, and then the same for the other cloud types. Or if we're just describing the overall appearance of it, we can use cumulus for puffy, stratus for the blanket-like, cirrus for the light wispy ones. So combining these together, we can describe a lot about kind of cloud types there. Again, this slide right here just shows an example. A middle level smooth gray cloud would be called altostratus. And then these are other ones: low altitude gray smooth cloud, high level puffy fair weather, very tall puffy storm cloud, high elevation feathery cloud. So let's pick one of these. Let's pick that high level feathery cloud. Come back here. High level is cirro. Feathery is cirrus. So a high level feathery cloud would be a cirro-cirrus cloud. That's funny just to say, cirro-cirrus. So that's how we go about naming clouds. Boop, 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 cirrus, bam. And here are some pictures. Here's a big old classic puffy cumulus cloud. Here's what a stratus cloud looks like. You see that nice blanket shape that's associated with it. Some altocumulus, so it's a little higher up in the atmosphere. This altocumulus, about 5,000 to 20,000 feet. Altostratus, same deal. This altostratus is just like this one, just higher up in elevation. Cirrus, my high wispy dudes. Cirrostratus, very, very high stratus clouds. You see this, I feel, very frequently at the ocean, kind of like what we see here in this picture. My cumulonimbus, my big, when you ever have clouds that have that really big, long neck or anvil-like shape, that's a lot of moisture, a lot of uplift. That's how you can get a lot of severe weather with those clouds. So precipitation, this is water that falls from clouds. We get rain, snow, sleet, hail. Coalescence is this idea that we need water droplets to collide and join together to form a very large droplet. Snow, sleet, hail depends on the vertical variation in temperature in the atmosphere. So here's a picture that shows coalescence between snow and rain. This page right here, this chart, goes through the difference between rain, snow, freezing rain, hail. Pretty much the difference is what is the layer of temperature of the atmosphere the moisture is falling through. So you're going to want to take a look at this. slide right here to get a really good understanding of what's going on between these different ones, between rain, snow, sleet, hail. Water cycle, we already spoke about this way back at the very beginning of the year during our biogeochemical cycles. We know it's the movement of water between the atmosphere and Earth's surface. We got some rain, we get some snow, we got some sleet here. Essentially what sleet is, it starts as snow, it encounters an area of warm air, that snow melts into rain and then it refreezes before it hits the ground. Freezing rain is when it rains all the way down to the surface and then the water kind of flash freezes right at the surface in the ice. Hail is where we have icicles that are constantly thrown back up into the atmosphere, sink down enough just to melt, raise back up. So it's the constant process of freezing and melting to get those really big chunks of hail. Can be up to inches in diameter. And that's it for the main chunk of notes here. There's some extra meteorology notes that if you want to go through, you can, but we'll kind of double back to those as we go. So you might want to go back through this PowerPoint for this section, look at how clouds form, how we name the clouds, and then again, look at this specific slide about the difference between rain, snow, sleet, freezing rain, and hail, because there are some differences between them and how they form really are dependent on what are the temperatures and the layers of the atmosphere in which they're falling through. So if you have any questions for me, please go ahead, reach out, let me know. If not, have a good rest of your day, and we'll see you next time. Bye-bye.